Welcome to the second video in the series of videos on trigonometric ratios. In this video we're going to look at the following angles, ratio for the following angles, 45, 90 and 0. In the previous video we looked at the ratio for 30 and 60 degrees, and we understood the formation of this special triangle from an equilateral triangle, right? So let's get started. Let's visualize a 45 degree triangle. Here is a 45 degree isosceles triangle, so both the angles are 45 degrees, and let's assume both the sides are of unit distance, or which it could be any value, but let's take it as unit distance. And then your hypotenuse would be root 2 by Pythagoras theorem, right? So with this triangle we could try to find out the values of sine 45, cos 45 and tan 45 the way we did in the previous video. So please pause the video here and try to find those values. So in this triangle, for this 45 degrees, this would be the perpendicular, this would be the base, and this would be the hypotenuse. So some people have, so sine 45 is perpendicular by hypotenuse, that is 1 by root 2. Cos 45 is curly brown hair, base by hypotenuse, so this is base by hypotenuse, that's also 1 by root 2. And tan 45 is still painted black, perpendicular by base, that is 1 by 1, that's equal to 1. So this was quite easy to remember, because sine and cos have same value for 45 degrees, which is 1 by root 2 and 1 by root 2, and tan 45 has a value of 1. So now let's look at the 90 degree angle, and let's visualize that in the form of a triangle. So here is a triangle with which is a very, very long triangle in terms of the height, or the perpendicular distance is very, very high, large in comparison to the base, which is approximately 0. And in such a case you will have the opposite angle to the perpendicular also close to 90 degrees. So in this triangle, let's try to find what are the sine, cos and tan values for 90 degrees. So pause the video and try this. In this triangle, for this angle, when we are trying to find the sine and cos for this angle, and as you can see, this is an approximation. Our perpendicular is here and the base is here and the height is here. So sine 90 is perpendicular by hypotenuse, that is h by h, so that is 1. Cos 90 is base by hypotenuse, curly brown hair, so that is 0 by h, that is 0. And tan 90 is perpendicular by base, this is perpendicular by base, that would be h by 0, and that would be close to infinity. As you can imagine, if you want to imagine a triangle which is of angle 0, then the triangle would look like this. Here the angle is 0, and you have the hypotenuse, and the base and the hypotenuse are of almost same distance because the perpendicular is almost close to 0. So please pause the video here and try to find the values of sine 0, cos 0 and tan 0. So here again you have sine is perpendicular by hypotenuse, so that will be 0 divided by h, that will be 0. Cos 0 is base by hypotenuse, that will be approximately h by h, that is 1. And tan 0 is perpendicular by base, that is 0 by b is close to h, and that is 0. So those are the values for sine, cos and tan 0. So we have covered 45 degrees, 0 degrees, and 90 degrees as special cases. So let's quickly summarize with a checkpoint. So here are the checkpoint questions. Now, one thing to remember is, if you have, let's say, for example, sine 0, you get it as 0. So the value of sine 0 is 0. Then the value of cosecant x is 1 by sine x. So cosecant theta, cosecant 0 is 1 by sine 0. So that's 1 by 0. So what you get is infinity, right? So that's how you can fill the values for any case when the value is 0. So in this case, sine 90 is 1. So cosecant 90 would be 1 by sine 90, which is also 1, right? So cosecant 90 is 1 by sine 90, and that's equal to 1 by 1, that's 1. So that's how you can find these values. So yeah, you can pause the video and try to fill this table for all the other trigonometric angles. I hope you enjoyed this video. See you in the next one, where we will do numericals with these values. See you until then. Bye.